Alright, last time when we did BOBO, what did that stand for? Bigger on bottom, 0. So when your degree is bigger on bottom, your asymptote's at 0. If it's bigger on top, it's slanted. And if the exponents are the same, divide your coefficient. So let's look at the one we have here. Let's look at what it would have. We have 3x cubed plus 2 over x squared minus x minus 7. Is the degree bigger on the bottom? Is it bigger on the top? Or are those exponents the same? It's bigger on top. Okay, so this would be the bots. The bigger on top slanted have slanted asymptotes. Slanted asymptotes are also referred to as oblique asymptotes. That is their technical name. We can find oblique asymptotes using polynomial long division. Now, it is slightly easier than regular polynomial long division because you actually don't have to finish the whole problem. You want to do just enough polynomial long division to get a y equals mx plus b in your quotient. So if you look, I didn't actually even finish this problem. I did just enough long division to get what here would be an mx and then a plus b, because my slanted asymptote should look like a little linear function. So you don't need to finish it, you don't need to find a remainder or anything like that. You're just doing a tiny little bit of it. I did kind of put a little reminder here. If your polynomial is missing any terms, you want to make sure you write in that there's 0 of them whenever you do your long division. That's true for both the top and bottom. Let's try one. Y'all ready to try one? Okay. We're going to start the same way we started the last one. We're going to start by factoring it just to check if any factors cancel, see if there's any holes in the function. Which part of this does not cancel? The top or the bottom? Or sorry, not cancel. Which part of this does not factor? The bottom. The top, though, looks like I split the middle factoring. I'm going to do it on a Post-it to keep my work clean. 2x squared plus 7x plus 3. So remember, for split the middle, we're looking for two numbers that multiply to a times c, which would be 6, but they need to add to b, which would be 7. 6 and 1. Very good. Remember, those don't go directly in your parentheses, but you are going to split your middle term into a 6x and a 1x, and then bring down your 3. And then remember, after that, then you group and group. And we start looking for the little baby GCF. What's the little baby GCF of this first group? 2x. And then if I divided both terms by 2x, what am I going to be left with? X plus 3. Good. And then the little baby GCF of the back group? 1. Right, which if you divide by 1, does anything change? No, still x plus 3. At this point, our parentheses match. Is that a good sign?
Yes.
Yes. So I'm going to take the factors, I'm going to transfer them over to my numerator. One of them is 2x plus 1, bless you. The other one is x plus 3. So looking through that, does anything cancel? No. What does that tell me about my graph? There's no holes. There's no holes. Which is kind of a bummer because sometimes you get an easier graph when there's holes, but oh well, no holes. Okay, and then because I'm a creature of habit, what do I usually find after that? The vertical asymptote. Remind me how we do that again? Yep. Take the denominator, set it equal to 0, and then solve. So we'll have x plus 2 equals 0, which means my vertical asymptote is that x equals -2. Okay, for my horizontal asymptote, remember it might not necessarily be horizontal, so I'm going to say HA/EBA, end behavior, because it might not be a horizontal one. And this is where we need to look at the degree. What is the degree of the numerator? 2. What's the degree of the denominator? 1. So is the degree bigger on the bottom, bigger on the top, or are they the same? Bigger on top. Bigger on top means slanted asymptote. So once I know that it's slanted, I am going to have to do a little bit of long division. So I'm going to take the original function, not the factored one. It's hard to do long division with factors, but I'm going to take the original one. I'm going to set up a little long division. So we're going to divide 2x squared plus 7x plus 3 by the denominator, which is x plus 2. So we're looking at the first term on the outside and the first term on the inside. And we're saying, what do I need to multiply x by to get it to be 2x squared? 2x. Yeah, so 2x goes in my quotient up top. And then I need to take that 2x and I'm going to distribute off the side. 2x times x is 2x squared. 2x times 2 is 4x. And then do y'all remember, do we add or subtract here? You subtract, right. And remember, if you're going to make a mistake anywhere, it's not because you don't know how to divide polynomials, it's because you don't know how to subtract. So be careful with your subtracting. 2x squared minus 2x squared cancels. 7x minus 4x is 3x. Okay, and then, I mean, technically you could do this without bringing this down, but just for proper form, I'll bring that 3 down. And then we're going to repeat that process. We're going to look at the term outside, the x, and the first term on the bottom, 3x. What do I need to multiply x by to get it to be 3x? 3. Positive 3 or negative 3? Positive 3. Do I need to continue? No. You don't need to take that 3 and distribute it. You don't need to find a remainder. Don't waste your time. All you need is enough to see a mx plus b in your quotient. So my equation of my slanted asymptote is going to be at y equals 2x plus 3. If you want to finish for funsies, you can, but you don't have to. You just need enough to see mx plus b. Next up, x-intercepts and y-intercepts. X-intercept, y-intercept. The x-intercept, remember, that's when y equals 0, which in this case, I guess we would say f of x equals 0. So let's say 0 equals 2x plus 1 times x plus 3 over x plus 2. But what's going to happen to the denominator? It's going to cancel, right? We're going to multiply by it to get it to cancel here, but then when we multiply by it on the left, it's going to turn to 0. So I'm just going to cancel it out. And I'll say 0 equals, and I have 2 factors. So how many x-intercepts am I going to have? 2. One when 2x plus 1 equals 0. Another when x plus 3 equals 0. So one of them is at negative 1 over 2. The other is at negative 3. Usually for intercepts, though, how do we write our answers? Points, right. So we'll write one of them is negative 1/2, 0. The other is negative 3, 0. Look at what I wrote. Come on, brain. Negative 3, 0. Negative 3, 0. Okay, found my x-intercepts. Y-intercept, remember we can plug in what for what? 0 for x. Good. Okay, 0 for x. There's actually, do y'all think it's faster to plug it into the original or the factored one? It's easier to plug it into the original. Because think, everywhere you have an x, it's going to turn to 0. So this turns to 0, this turns to 0, this turns to 0. So it's literally just 3 over 2. Look at our little mental math. But it doesn't matter. You should get the same answer either way. So I'll have, let's see, 2 times 0 squared plus 7 times 0 plus 3 over 0 plus 2, which leaves you with 3 over 2. As a point, I would write that as how? 0 and then 3 over 2. Very good. Okay. Before we graph it, I'm just going to kind of show you what these graphs might look like. I'm going to use a post-it for this. Because slanted asymptote graphs do look different than our regular ones. So I'm just going to draw just a boring old coordinate plane. Wow, beautiful. I'm going to put some random, I'm going to put one vertical asymptote. Y'all can see that? Y'all can see that vertical asymptote? Okay. And then I'm going to draw in like a pretend slanted asymptote for this one. So when you find your branches of these, they're going to show up in one of 2 places. The branches might be in these kind of smaller pizza slice areas. And you'll have branches here. So that's one spot your 2 branches might be. Or they'll be in the other areas. Or you'll have branches in kind of like the larger area. A branch here. And a branch here. So it's not like one pizza slice, one large area. It's either both are pizza slices or both large areas. So we're going to put all of our information on our graph, see if we can figure out if it's in the pizza slice or the large area. Okay, I'm going to start by putting my vertical asymptote on my graph. It's at -2. -2. And then remember, we have a slanted asymptote, which means we're going to have to graph this 2x plus 3 algebra 1 style. That's a slope and y-intercept. Bless you. Which part should I graph first? The y-intercept. What's my y-intercept at? 3. And then my slope is 2, which means what for my graph? Up 2, right 1. If you have an ID badge or a note card or a ruler or just a steady hand, you can draw that line. I heard there's no AP Human note cards this week. Because I was like, get out your Human Geo note cards, and everyone's like, we don't have any this week.
Maybe next week.
Oh, okay. I'll hope for you. Okay, I got my 2 asymptotes on the graph. How many points do I have to graph? Look at all we found. How many points do I have to graph? I have 3, yes. So hopefully they're on different branches. If not, we'll have to find an extra point. So let's see, I've got one at -0.5, 0. I have one at -3, 0. And then one at 0, 3/2. Where's 0, 3/2 going to be? 1.5 up, right. Okay, so those branches, are we going to have pizza slice branches or large branches? Large branches. Do we have enough points to graph them? Yes. So we're going to use our point and we're going to use the asymptotes to kind of guide what it looks like. For my leftmost point, as it goes up, it's going to follow the vertical asymptote. As it goes down, it's going to turn and follow the slanted asymptote. Okay, for the points that are on the right side, as they go up, they're going to follow the slanted asymptote and kind of turn. And as they go down, they're going to follow the vertical asymptote. Before you flip your paper over, we are going to do domain and range for these in set notation.
This one's not as painful as yesterday.
Your graph has a weird turn to it that should not have. You see, yours goes like this, or it needs to follow the vertical. Well, yesterday was a block day, so that was painful. Okay, for my domain, do I have any x values that I need to exclude that are not in my domain? -2, very good. So we want to say that it's all real numbers except for -2. X is a real number except for -2. Why not -2 again? That's where your asymptote is, right. For my range, are there any y's that we're going to need to exclude? Is that a y? Look at where your graph is. Look, take your little fingers, start from the bottom, follow it up. Are there any y's that we hop over? We hop over 3? Did I ever lift my finger up and hop over 3? Again, take your little fingers, follow it up. Am I hopping over any y's? So am I skipping any y's? So what am I going to write? All real numbers. Right. We didn't need to skip over any of them. Basically, every single point for y's would be included because there's none that have open dots. There's none that we have hop over with a horizontal asymptote. Y is a real number. Oh, for this slanted. We'll see on the next one. All right, let's look at our second one. What are we going to start by doing? factoring it because we want to see, are there any holes that might cancel out and go away? Which part does not factor? The top or the bottom? The bottom, right. That's a little linear function. The top, though, let me factor that on a Post-it so my paper does not get messy. All right, for splitting the middle, we're looking for two numbers that multiply to A times C, so that's 30, but they need to add to B, which is 11. What are those two? Yes, Steph, good job, 6 and 5. 2x squared plus 6x plus 5x plus 15. We'll group and group.
Oh, I just did it wrong.
GCF of the first group? 2x. And then if I divide both by 2x? Good. GCF of the back group? Plus 5. And if I divide both by 5? Alright, so I can see what my factors are going to be. One of them is going to be x plus 3. One of them is going to be 2x plus 5. Alright, let's think about canceling. Can I cancel this 2x and this 2x? No, they're both trapped in a little addition. Can I cancel this 3 and this 3? No, again, both trapped in addition. What does that tell me about my graph then? There's no holes in the graph. Right. Okay, creature of habit. What do I like to find next? Vertical asymptote. That's again where the denominator equals 0. How would I solve this little equation where my denominator equals 0? Subtract 3 first. Good. Then divide by 2. We get x equals negative 3 over 2. Or if you were going to put that on a graph, you could write it as negative 1.5. It's kind of the same thing. Okay, and then our horizontal, or possibly just in behavior asymptote, because it might not be horizontal. We're looking at the degree. Highest exponent on the top, highest exponent on the bottom. What's my degree of the top? 2. What's the degree of the bottom? 1. So is it bigger on bottom? Is it bigger on the top? Or are those exponents the same? Bigger on top. Remember our acronym bigger on top means it is slanted. And how do we find that slanted asymptote again? Long division. Just a tiny little bit of long division. Do you use the original or the factored one? The original. I don't even know how to do long division with factors. So original it is. So we'll have 2x plus 3 in the divisor. Inside 2x squared plus 11x plus 15. Okay, we're looking at the first term outside and the first term inside. What would we need to multiply 2x by to get it to become a 2x squared? Just a single x. Very good. And then I'm going to take just that single x. I'm going to distribute off the side. X times 2x is 2x squared. X times 3 is 3x. Remember, if you're going to make a mistake anywhere, it's right here. So be careful with any subtracting. Both need to be subtracted. The first two cancel when you subtract. The second two become 8x. Technically, you don't need to bring the next term down when we're doing this, but just for proper form, I will. And then we're going to repeat that process. We're looking at the 2x outside, and we're looking at the 8x on the bottom. What do I need to multiply 2x by to get to be 8x? A 4. Positive 4 or negative 4? Positive 4. Do I need to continue? No. You don't need to distribute. You don't need to subtract. You don't need to find a remainder. You need to do just enough of the polynomial long division to get an mx plus b. So my slanted equation would be y equals x plus 4. Okay, and then lastly, finding our x and y intercepts. The x-intercept, remember that's when y equals 0. So I'm going to put my 0 here. Remember that ends up canceling with your denominator because you're going to multiply by your denominator. It's going to cancel out and turn into 0 equals the numerator. So I'm going to put 0 equals the 2 factors in my numerator. How many x-intercepts am I going to have then? 2 x-intercepts, right. 1 when x plus 3 equals 0. 1 when 2x plus 5 equals 0. But remember, don't leave your intercepts looking like this. They look like asymptotes when you write them like this, so I always switch them and write them as points instead. And then lastly, finding my y-intercept. Now that you know my trick, which one is it easier to plug it into? The factor or the original? The original, because everywhere there's a letter, it's just going to become a 0. So I'll take my little finger. If there's 0, I'm covering them up. 15 over 3, what do I got? 5. So we'll have y equals 2 times 0 squared plus 11 times 0 plus 15 over 2 times 0 plus 3, which is 15 over 3, which is 5. As an ordered pair, though, what would we write? 0, 5. All right, we're going to put all this on the graph. We're going to hope and pray that that's enough information that we don't have to find more points, but who knows? I'm going to start by doing the asymptote. All right, we'll have a vertical asymptote at -1 1/2. What? What? Did I do it wrong? Did I do something wrong? Oh, okay. All right, -1 1/2, so in between -1 and -2, we'll have an end behavior slanted asymptote following this little linear function that you learned how to graph in Algebra 1. I'll start by graphing the y-intercept at 4 as a slope of 1, which means what for my rise over run? Up 1, right 1. Feel free to use a note card, ruler, ID badge, whatever you got to do a nice straight slanted asymptote. Okay, and then we have 3 points. 2 of them are x-intercepts. 1 of them is a y-intercept that we're going to put on the graph. And we're going to see if that's enough information or if we need to find more points. So 1 of them is at -3, 0. -1, 2, 3, 0. 1 is at -2 1/2, 0. 1, 2 1/2. I think those are really close to each other. And then 1 of them is at 0, 5. A y-intercept at 0, 5. Looking at where those points landed, are we going to have pizza slice branches or big branches? Pizza slice branches. Do I have enough information to graph those pizza slice branches? Yeah. 1 point per branch. Just use the asymptotes to kind of guide what the rest of it looks like. This one's going to kind of turn, follow the vertical asymptote. It'll follow the slanted asymptote as it goes up and right. The bottom one, do you think, what do you think is going to happen here? You think they're just going to connect? It'll be a little bloop, where it just kind of goes up, passes back, goes back through. And then use, well, my pen, my pen followed the lines on the wood underneath and ooh. Okay. All right, for the domain and range, we're only going to do the domain. Does anyone know why we're not going to do the range for this one? There's a gap in the middle, and I don't know what these numbers are. Like, I don't know how high this goes. If we had access to a calculator, you could find it more exact, or you could do some calculus and find it exact. Choose your favorite. We're just going to skip it, though. We will do the domain. Okay. Okay, so remember domain, that's your x's, that's left to right. So this graph exists everywhere left to right except for what x? Negative 3 over 2, or negative 1.5, whatever you want to call it. X is a real number except for negative 3/2, which is the vertical asymptote. And again, we're skipping the range on this one because if I'm going bottom to top, I would have to actually know what number this is that it stops at, and then pick it up here and know what number it is that it keeps going at. So skipping that for now.